What is up, y'all? Happy Tuesday. This is our warm up today. All right. How many of the following scale factors are enlargements? Now, to get credit for the warm up, make sure you are logged into the Pear Deck posted on Schoology. Everybody should be on their Chromebooks at your seats right now. Okay. How many of the following scale factors are enlargements? We have five choices here. We have a lot of fractions. We have a decimal, we have an integer, okay? You can answer just with a number. If you think there's five enlargements in front of you, answer five. Anything from 1 to 5, because there's five different numbers, all right? Take 2 minutes on this. Once the 2 minutes are up, go ahead and continue to play the video, and we'll get into our lesson. All right, real quick, one's got to go. We got chicken wings, tacos, hamburgers, pizza. Go ahead and type in which one you got to get rid of in your Pear Deck on your Chromebook. I am personally getting rid of chicken wings. I'm sorry. You still got chicken thighs. You still got grilled chicken, fried chicken. I can get rid of chicken wings. I can't. The other three got to keep in my life. I'm sorry. Let me know why, too. You got whole text box. Tell me anything. All right. Scale factor and coordinate points. All right, continuing on the amazing things that we did yesterday. Let me move my face over here. Okay. How do I find the scale factor between a pre-image and image? And how do I write a dilation rule? Tell me how. Look at him. He's like, help, please. I got you. Check it out. Scale factor. Okay. Scale factor can be represented as a fraction. We talked about pre-image and image. New always goes over old, just like in life, right? I prefer new things over old things. I prefer the iPhone. Where are they on? 14. I prefer that to the iPhone 3. I prefer the PS5 to the PS2, right? PS2, trust me, had some great days. Okay, I played the living crap out of that thing. It was amazing. Anyway, scale factor. Go ahead while you're following along. I think it would be really helpful for you guys to actually use the text box feature on Pear Deck on your computer and type in as I'm writing on the screen. Okay. So just like you would with a paper copy of the notes, we're going to try to do that with your computer today. The ratio between the corresponding parts of similar figures. That is what a scale factor is. It's a ratio, right? A ratio can be represented as a fraction. The ratio can be found by dividing a corresponding ordered pair of the pre-image. Apologize for my handwriting here. Of the pre-image and image. All right, so pre-image is what we start with, right? Just like uh, pre-game in football, basketball, sports, right? Pre-image is what we start with. Image is what we end with. Now, review from yesterday. Enlargement, SF. SF stands for scale factor. Enlargement scale factor is greater than 1. I will say greater than. Meanwhile, a reduction is less than 1. All right. So when we see a fraction as a scale factor, we can think of it as a ratio that was found by dividing the pre-image and image. And as you see up here, image always goes on top. It's always new over old. Image divided by pre-image. There we go. Dilation rule. Scale factor is always multiplying. All right, that is key for this unit. We're not adding, we're not subtracting, we're not dividing, we are only multiplying times the scale factor. Whenever you see that word scale factor, we automatically know we multiplied by something. Multiplying the pre-image ordered pairs or vertices to create an enlargement or reduction. So this rule down here that you'll see, let me move my face again. The rule, if I take an x and y value as an ordered pair, I multiply it times k. So that's why k is next to x, that's why k is next to y, because we're multiplying times the scale factor to get our new coordinates. Okay, getting into the nitty gritty here. Here we go. Example number 1. Use the table below to dilate the triangle by a scale factor of 2/3. So we have a picture here, right? We have points A, B, and C connected to make a triangle on the little coordinate grid on your left-hand side of your screen right now. First thing we're going to do is label up our pre-image. Our pre-image is what we're looking at right here, okay? We're going to look at where the points are located and write down some ordered pairs for each letter, okay? Letter A, right about here. Looks like we're at 3 on the x-axis, 3 on the y-axis. All right, so up here, where it says pre-image A, I'm going to write 3, comma, 3. As I'm going through this, guys, I recommend you either try to write with your finger on your touchscreen or use a text box to fill in the answers as I'm going over it. That'll do for your notes today. All right, letter B. Let me change the color. We see right here, looks like we're at about 6 on the x-axis, 6 on the y-axis. So I'll label this as 6, comma 6 right here. So all I'm doing is writing down the ordered pairs from the picture. Letter C. Looks like we're at 9 on the x-axis. I'll fill in 9. And then looks like we're at about 3 on the y-axis. So 9, comma 3. Perfect. Okay, here we go. Where's my eraser? There we go. Perfect. Okay. Multiply by the scale factor. Now, if we read the problem over again, use the table below to dilate the triangle by a scale factor of 2/3. Okay. So whenever I see scale factor, I know that that is going to be multiplying. So essentially what I'm doing is multiplying times 2/3 to everything. Times 2/3. All right. So I'm just writing that in here. Now, this is where your handy dandy calculator is going to come into play. 2/3 times 3. What is 2/3 of 3? Well, that's going to be 2. And you can see that if you did your calculator, 3 times 2/3, you should get an answer of 2. And I've got the same x value, same y value. So my new coordinates for that point, my image, letter A is going to be at 2, comma 2. All right, next one. For letter B, multiplying 6 times 2/3. If you try that in your calculator, you should end up with 4. And we have multiple of the same value for x and y, 6 and 6. So I know it's going to be 4, comma 4. Last one, multiply both these numbers by 2/3. First off, what is 9 times 2/3? 9 times 2/3, calculator should give you 6 for that. So x value would be 6 here. And for the y value, we already multiplied 3 times 2/3. Up here, we know that 3 times 2/3 would give me 2. So 6, comma 2 would be my new coordinate for that image. All right. Was my dilation an enlargement or a reduction? Well, I can even take it one step further. You guys do not have to do this on your screen, but check it out. If I actually plot all three of these points, let me plot this one first. 2, comma 2, right about here. I'll call this A with an apostrophe on it. Next one, let's do 4, comma 4, would be about right here. And this would be B with the apostrophe on it. Letter C would be at 6 and 2, right about here. Connect the dots best I can. It's not going to be perfect. But as we can see, the pre-image was larger than our image. Essentially, what we did is we took this triangle, we made it smaller. When we make something smaller, that is a reduction. I also know that this number, 2/3, is less than 1. Whenever I multiply something times a number less than 1, it is going to be a reduction. All right, why was it a reduction? Because the shape got smaller. Now, as far as writing the dilation rule, this is something that all we got to do is write out what we did here. All we did is multiply x and y. So I'm going to write x and y like this. All I did was multiply times 2/3. So all I'm going to do is put 2/3 right next to x, like this, and right next to y. And boom, there you have it. That's your rule. All I do is write the scale factor right next to x and right next to y. So 2/3 x, comma, 2/3 y. That's your dilation rule right there. All right. Whew. Feels like a lot of work, but honestly, you guys are going to be crushing it. The more practice we get on this, the easier it's going to get. Example number 2. Same sort of thing, okay? Just want to show you guys one more time. So, first thing we do is this little part of the... Let me get my pen back out. First thing we're doing is this part of the table. Just looking at our picture and writing down our coordinates for A, B, and C. All right, so start with A. Let's do that in blue. A right here. Looks like we're at 4 for our x value. If we went down, looks like we're at 4. And it looks like we're at 8 for our y value. So I'm going to write 4, comma, 8. All right, there we go. Letter B. Looks like we're at all the way down here at 12 and 16. So we'll write 12, comma, 16. And again, I highly recommend you guys follow along and write this stuff down on your Chromebook as we're going over this. Letter C. We've got 16 and 8. All right, 16, comma 8. There we go. All right, looked at our picture, wrote down the coordinates, looking great. Okay, scale factor of 2. That is what we're multiplying by on this one. Dilate a triangle by a scale factor of 2. So again, remember, scale factor just means multiply. All right, so all we're doing is taking those numbers we just wrote down, multiplying everything times 2. All right, so essentially what we're going to be doing is something like this. We're just going to rewrite, and this is me showing what I'm multiplying by. You guys could honestly skip this part of the table, this part that I'm putting in a purple box. You guys do not have to write this down. Just showing you essentially what we're doing here. So we're just multiplying all these numbers times 2. While I'm doing this, you guys can fill out that last part on the right-hand side. And I do want you guys to try that part and the bottom on your own. All right. Go ahead and take about 2 minutes to try to fill out the rest of this slide on your own, you can feel free to pause the video and then play it again once the 2 minutes have gone by. All right. Our 2 minutes are up. Let's see what answers we got here. When I multiply both of these by 2, I should get the new image should be 8, comma 16 for point A. For point B, you should get 24 and 32. Point C should get 32 and 16. Now, I am not going to have you guys draw that on this picture on the left-hand side. Don't worry about that. I do want you to answer this bottom question, though. Was it enlargement or a reduction? Well, what happened to my numbers? Did they get smaller? No. My numbers got bigger. When my numbers get bigger, that is an enlargement. So I'm going to circle enlargement. Writing my dilation rule, remember, always just start with x comma y. All we're going to do is put our scale factor right next to x and right next to y. So my scale factor of 2 is just going to be written right in front of both of these. So my dilation rule sounds fancy, but really not too bad. 2x and 2y. All right. This will be the last example that I do with you. Example number 3. The table shows the coordinates of a pre-image and its image. So essentially, they're giving us all the answers. We're trying to figure out, hold on, what did they do to get to these new numbers? We're trying to find the scale factor, as number 1 states for us, okay? So we have pre-image. We have A at -6 and 3. And then we have the new image, A apostrophe, at -2 and 1. Well, how did I get from -6? How did I get from -6 to -2? Now, you might be thinking, wait, -6 divided by 3 is -2. Would that mean our scale factor is 3? Not necessarily, because scale factor is always multiplying, right? So essentially what I'm thinking of is, what did I have to multiply by to get from -6 to -2? Well, the same thing as dividing by 3 would be multiplying times 1/3. And you can do that with anything. Same thing as dividing by 4 would be multiplying times 1/4. Same thing as dividing by 5 would be multiplying times 1/5. And if we use that for everything, we can test that out with everything. Go ahead and try with your calculator. See if you can multiply 6 times 1/3 and get the correct answers for both of these. Does 6 times 1/3 equals 2? Does 3 times 1/3 equal 1? Right? And we can do it all the way down. We actually have the same numbers over and over again, so no point in going past B. This is our scale factor right here. We can use that calculator to confirm our answer, but this is our scale factor, 1/3. All right? Is that an enlargement or reduction? Well, if I start with my pre-image and I move to my image, I notice that all these numbers got smaller. When the numbers get smaller, it is a reduction. And I'll write that down. Numbers got smaller. This is exactly the type of work we're looking for on the next slide when you're working on your own. All right, the dilation rule. Always start with your x comma y. What did I have to multiply by to get from the pre-image to the image? 1/3. That's our scale factor. So I'm just going to write the scale factor right in front of x and right in front of y, just like this. And boom, I'm done. All right. Dilation rule: one third x, one third y. Scale factor was multiplied times one third. It was a reduction because my numbers got smaller. All right, guys. So the way we're going to finish out the pair deck is number 4, 5, and 6 are going to be all you. All right. I want you guys to practice on your own to come up with answers for 4, 5, and 6. Now, very, very similar to what we did on number 3. All right. Exact type of problem is the same. Everything is formatted the same. It's just different numbers in this table over here. All right, so we're going to find the scale factor. What did I have to multiply by? We're going to find, is it an enlargement or a reduction? And then we're going to write our dilation rule down here. So 3 different things we're looking for on example 4, example 5, and example 6. Now, if you do have time, go ahead and try the Schoology assignment out. It is posted on our Schoology page, scale factor and coordinate points guided notes. That's what we just went over today. Now, if you did not get a chance to finish the one from last time, do that first. That is of the most importance. This one, I'm considering extra practice right now. Go ahead and work in partners on this. It is a little bit more challenging than the one on Monday, so I'm okay with you guys working together a little bit. Feel free to ask your teachers for help. I will be able to review a little bit of this with you guys because I will be back on Wednesday and Thursday this week. Very much looking forward to seeing you guys again. Have a great day.